Hello class, welcome to this video on 11.2 practice. So we're going to look at 3 questions from the practice, and we are only assigning number 2 and 3, but I'm going to go over number 1 as well. So let's go ahead and get started. So it says, in each of the following settings, decide whether you should use 2 sample T procedures to perform inference about a difference in means or paired T procedures to perform inference about a mean difference. Explain your choice. All right, so part A, it says to compare the average weight gain of pigs fed 2 different diets, 9 pairs of pigs were used. The pigs in each pair were litter mates. A coin toss was used to decide which pig in each pair got diet A and which got diet B. So this one's pretty, there's a lot of clues here. You know, it says pigs in each pair, and then you're saying average weight gain of pigs feeding 2 different diets, so 9 pairs of pigs. So this is clearly a paired t-test, right? So we're going to use a paired t-test, which means it's a 1 sample t-test for the mean difference, okay? So we're going to say, and it says explain your choice. So this is a matched pairs design. With pairs of pigs. With pairs of pigs in the same litter. So they were litter mates. Each pig in the pair receiving 1 treatment, and the other pig the other treatment. Okay, so then part B says separate random samples of male and female college professors, or separate random samples of male and female college professors are taken. 1, we wish to compare the average salaries of male and female teachers. Okay, so they just want to compare the average salaries of 2 separate samples, random samples. They're separate, and so they're independent from each other. So we're doing a 2 sample test. Okay, so this is a 2 sample t-test. As the data are produced using 2 distinct groups. Or we could say two distinct groups of people, or maybe 2 distinct, or maybe let's do independent. So 2 independent random samples. And in parentheses, male and female professors. All right, and then part C, it says to test effects of a new fertilizer, 100 plots are treated with the new fertilizer, and 100 plots are treated with another fertilizer. A computer's random number generator is used to determine which plots get which fertilizer. So these are 2 different independent plots, right? 1 with new fertilizer, 1 with another fertilizer. These are different plots of land receiving the different fertilizers. So this is going to be 2 samples, okay? We have a 2 sample t-test. Since data comes from 2 independent, distinct groups of plots, or we could say in a randomized experiment. Okay, all right, and then let's look at part D. So it says to test aware characteristics of two tire brands, A and B, Each of 50 cars of the same make and model is randomly assigned brand A tires or brand B tires. Okay, so we're looking at 2 tire brands. And then, so 2 tire brands, and then we have, so these are independent ones. So this is going to be another 2 sample. Oops, hold on, let me scroll up here. All right, so 2 sample. T-test as data produced. And they're randomly assigned, so we have 2 distinct groups using 2 distinct groups of cars in a randomized experiment. All right, and then E, the last part here, it says to test the effect of background music on productivity, factory workers are observed. For 1 month, each subject works without music. For another month, the subject works while listening to music on an MP3 player. The month in which each subject listens to music is determined by a coin toss. So it's each subject is getting 1 month with music, 1 month without music. So it's the same person, so it's a paired t-test, okay? So we have a paired t-test as this is a matched pairs experimental design. Where both treatments applied to each subject in a random order. All right, so let's look at the next question here. All right, so let's look at the next question. All right, so let's look at a second question. It says, many people think it's faster to order at the drive-thru than to order inside at fast food restaurants. To find out, Patrick and William used a random number generator to select 10 times over a 2-week period to visit a local Dunkin' Donuts restaurant. At each of these times, one boy ordered an iced coffee at the drive-thru and the other ordered an iced coffee at the counter inside. A coin flip determined who went inside and who went to the drive-thru. The table shows the times and seconds that it took for each boy to receive his iced coffee after he placed the order. All right, so it looks like on the same visit, you have one that did inside, one that did in the drive-thru. And so this looks like it's paired data, right? So we're looking at paired data. So we're going to do a 1 sample t-test for the mean difference, okay? So this is a paired t-test. Okay, so now that we established that, we're going to continue. It says, do these data provide convincing evidence at the 0.05 level of a true mean difference in service inside and out the drive-thru for this Dunkin' Donuts restaurant? Okay, so we're going to do a paired t-test, but let's go ahead and do our state condition. So, or our 4 steps here. So we're going to state our hypotheses. So we know we're dealing with a mean difference, right? So I'm going to do mu difference equals, and then we got our HA. And it says that of a true mean difference. Okay, is there convincing evidence of a true mean difference in the service times? So that means that there is no difference of the null hypothesis. There's no difference, right? And then for the alternative, we're going to say there's no difference, right? All right, and then we're going to define what mu difference is. So I'm going to say where the mu difference is equal to the true mean difference. And we're going to do, in this case, we're going to do inside minus drive-thru. And so the true mean difference in time it would take to receive iced coffee at Dunkin' Donuts after placing the order. All right, and then we're going to use alpha as 0.05. Okay. All right, so there's our state. So now let's do our plan. So our plan is to do a paired t-test, otherwise known as a two sample t-test for mu difference. And then we're going to need to list our conditions, so the random condition, and then see if they're satisfied. So it says here, so it says they use a random number generator to select 10 times over a 2-week period. Okay, so we can see that the times are randomly selected. All right, and then let's see our normal condition, or actually let's do the 10% condition here. Well, in this case, we have we don't really have to check the 10% condition because these are just 10 visits, right? They can easily have done more visits. Okay, so, but I'll write it down here. Don't have to check as there could be unlimited amount of visits. All right, and then we'll just go straight to the other condition, the normal condition. Okay, so we'll do the normal large sample condition. So we got the, in this case, if you look at the, let's see how many, we had 10 visits. So we have n difference is equal to 10, which is less than 30. And so that means we have to check the graph, right? So sample is small, but the dot plot, we're going to do a dot plot. And we're assuming that the dot plot's going to work out here, right? So we're going to, first we need to calculate the differences and then do the dot plot. But I'm going to just do the structure of the dot plot. And then, okay, so there's the axis. We're going to need to do all these, so 62 minus 5. So we're going to do the difference here. Inside minus drive-through. All right, and then we'll do the difference. All right, so let's do the differences. We got 62 minus 5, 13, and so on and so forth. All right, and so now we're going to go ahead and graph these on the dot plot. So we're going to do the difference. All right, so we're going to look at the data. And using that data, we're going to graph some dots. But I'm going to start at -5, got 0, 5, 10, and 15. All right, so we got a -5, we got a -3, we got 1, 2, 3, and 4. We got a 6 and 7. We got 13. And we have 11. All right. So there you go. So now if you see this, the dot plot does not show any strong skewness or outliers. And therefore we can proceed with the test. All right. So now we're going to do the do stage, but I'm going to shrink this, make this a little smaller. All right, so we're going to do the do stage. And so now we're going to need to, on the calculator, we're going to need to plug these in order to do the standard deviation and the mean. All right, so we're on the calculator, so we're going to hit stat, we're going to go to edit, and we're going to put in the numbers here. So these are the numbers that we got for the lists for the differences. So I already typed them in. And then go to stat, calculate, 1 var stats. Make sure list 1 is selected, go down to calculate, and then this is your X bar difference, and then this is your S difference, 5.646. All right, while we're also here, we'll go ahead and show you the do stage where we do the test. So we're going to go to stat, we're going to go to tests, and then we're going to do a t-test. Remember, we're doing a t-test because we're doing a paired t-test in this example. If you were doing a 2-sample t-test, then you would use number 4. But here we're going to do number 2. And we have data, so we can use our data from list 1. Our mu0, if you recall, was, well, here is going to be 0 for this. So we're going to use 0 here. And then we got list 1, and then it was a 2-tailed test right here. And then we're going to go to calculate. And again, that gives us our our t-score, gives us our p-value, and it gives us our x bar that we had earlier, and all of that. Okay, so there's both steps there. All right, so even though we did both steps, I'm gonna show the calculation as well. Okay. All right, so we got x bar difference. We have to list our statistics here for the step here. 3.9 seconds. We got seconds. We got S difference is 5.646. Oops, sorry. Let me just put a comma here. S difference equals 5.646. We got the N difference. This is the number of pairs that we have, which is 10 pairs. And then we can go ahead and calculate the T. So, and then the DF. So the DF is 10 minus 1, which is 9. All right, so let's go ahead and we're going to show how to do the p-value on the table using this and the t-score, but we're also going to calculate the p-value as well. Okay, so the p-value, or let's calculate the t-score first, actually. All right, so t is equal to x bar difference minus 0 over s difference over square root of n difference. Okay, so we got 3.9 minus 0 divided by 5.646 divided by square root of 10. And that gives us the approximately the 2.18 that we got earlier. And then this is a 2-tailed test, so I like to do the t distribution. All right, so you have a t equals negative 2.18 as well as a t equals positive 2.18. We shade both tails. All right. And then we can calculate the p-value. You can use TCDF, or you can just use the p-value that we got. But let me show you how to how to get the p-value from the table approximately. So you got 2.18 and then 9 for your DF. Okay, so let's go to our table. We got 9 for our DF. And we got 2.18. 2.18 is between these two values. And so therefore, your p-value is between those. Don't forget to double it because we are doing a two-tailed test. So it's really 2 times that, and then 2 times 0.025 and 2 times 0.05. It's between those two values. P-value is between 2 times 0.025 and then between 2 times 0.05. So it's between 0.05 and 0.1, 0.10 basically. Okay, and that makes sense because if you look at the p-value that we got from the calculator, which that's the only one you have to provide. I'm just showing you this for the table. You don't have to do this for this if you're using the calculator, okay? 0.0568. Now, if you use the table, then you would say, okay, I'm using the table for that. If you're using the calculator, then you have to say, okay, t-test. The calculator, you did t-test, right? So t-test calculator, something like that. T-test on the calculator, and you get that as your p-value. Okay? And then, you can also use the TCDF function, and that will give you a similar value. Let me show you that just so you have all 3 options. All right, let me show you the TCDF function. So just so you have all 3 options, and then you got, so we're going to do second vars, and then we're going to go down to TCDF, and then we're going to do our lower upper. So our lower is negative infinity. If you recall we had the 2 tails, right? I'm going to do the left tail. So I'm going to do negative infinity, and then the negative 2.18 that we had. Remember earlier on the graph I made negative 2.8 and I did a positive 2.8. And then I got 9 degrees of freedom, and then I'm going to double that, and that gives us 0.057, and recall that we had 0.0568. So it's pretty similar. All right, so regardless of which one you use, you'll be able to get a p-value and you'll be able to make a decision. Whether to reject or fail to reject. All right, so here we go. So now let's conclude. We are going to, in this case, our alpha is 0.05, so we're going to fail to reject, okay? So we're going to say because p-value is equal to 0.0568, which is greater than alpha, or which is 0.05, we fail to reject H sub O. We do not have convincing evidence the true mean difference which is inside minus drive-through. We do not have convincing evidence the true mean difference in time it would take to receive iced coffee at this Dunkin' Donuts after an order is not 0. All right, so that's it for that question. So now we're going to look at the last one for the homework, which is the homework was number 2 and 3. So it says to see if fish oil can help reduce blood pressure. Males with high blood pressure were recruited and randomly assigned to different treatments. 7 of the men were assigned to a 4-week diet that included fish oil. 7 other men were assigned to a 4-week diet that included a mixture of oils that approximated the types of fat in a typical diet. Each man's blood pressure was measured at the beginning of the study. At the end of the 4 weeks, each volunteer's blood pressure was measured again and the reduction in diastolic blood pressure was recorded. These differences are shown in the table. Note that a negative value means that the subject's blood pressure increased, okay? All right, so just because they say, so notice that they say differences, right? So they're actually recording the blood pressure difference. Just because they use the word difference doesn't mean that you're using a paired t-test where you're doing mu difference, right? It just means that, within that group, they calculated a difference, and then this is the value that they got, right? And then they're comparing these guys. It says that these are 2 different groups, okay? 7 of the men were assigned to a 4-week diet with fish oil, and then 7 other men were assigned to a 4-week diet, okay? So these are not the same men given fish oil and then they're given later on regular oil. These are 7 different men in each group, right? That were assigned. And then they were comparing. So they said each man's blood pressure was measured at the beginning of the study, and then at the end of the study, after they did the 4-week diet, they recorded the difference in blood pressure, right? Final minus initial, and then this is what they reported, right? But this is not a paired t-test. This is a 2-sample t-test. So you just want to be careful with that, okay? All right, so let's go ahead and do this. It says, do these data provide convincing evidence that fish oil produces blood pressure more on average than regular oil for men like these? All right, so let's go ahead and state. So we got H0. So we know we're doing a 2-sample t-test, which based on what I said, right? So it says that it helps reduce blood pressure more on average, right? So it helps reduce blood pressure. That fish oil helps to do that, okay? And remember, they said that a negative value means the blood pressure increased. So that means for this regular oil, their blood pressure actually decreased, okay? Or increased. That means that's an increase in blood pressure. So when we're talking about, we want to see if they reduced the blood pressure more, what we're saying is that we want the difference to be greater than 0, okay? So if this is a reduction because it's greater than 0, okay? And so that's very careful you need to be very careful to note that. So that means when we do the HA, we want it to be greater than 0, okay? When we subtract these, so fish oil, if we were to subtract fish oil minus this regular oil, right? Okay, so we're going to call this number 1 and then number 2, where mu1, so we're going to say mu1 minus mu2 is equal to 0, so there's no difference. And then if I subtract them and I get a positive difference, that means it got reduced. The blood pressure got reduced. That the difference, it being positive, means that one is more, the fish oil is more effective at reducing than the regular oil, okay? All right, so now that we got that taken care of, we can go ahead and define. So we're going to define mu1 and mu2. So mu1 is the true mean reduction in blood pressure for subjects like these who take fish oil. And mu2 is the true mean reduction in blood pressure for subjects like these who take regular oil. Okay, so now let's do the plan. So we are doing a 2-sample t-test for mu1 minus mu2. Let's go ahead and check our conditions. So random. We got random. We got randomized assignment to fish and regular oil treatment groups. Now we don't have to check 10%, so I'm not going to write that here, okay? We do not have to check 10% because we have random assignment here. They're not taking these guys, you're not picking these guys up, you're not sampling these guys without replacement. We're not doing that from a larger population. We are just recruiting people and randomly assigning them to an experiment, okay, to a treatment group. So we're not going to check 10% condition. We don't have to check that. All right, so the next thing we're going to check is the normal large sample. All right, so now we know that. Let's check here. We got N1 is equal to how many men? 2, 4, or people? 2, 4, 6, 7 each, right? Are small samples, meaning less than 30. So, but now we're going to draw a dot plot. We're going to do a parallel dot plot, okay? But the dot plots, I'm going to just put but the dot plots. All right, but the dot plots. All right, and then we're going to, see if it shows no strong skewness or anything like that, but I'm just going to say that now because we know that it's going to pass. Show no strong skewness or outliers. We know it's going to pass because if this were an actual a question, they're going to have you pass it so you can do the test, right? But they just want you to identify no strong skewness or outliers. Okay, so let's go ahead and do this. We're going to do the fish oil, and then we're going to do the regular oil. And we don't have to do it that. Remember, I don't have to do the graph that big, so I might reduce the graph later just for the sake of space. All right, so all right, so let's go ahead and do the graph here. All right, so we're going to record the change in blood pressure. All right, so we got -10, -5, 0, 5, 10, and 15. Okay, and then we're going to do a graph here like this, same thing. All right, so let's go ahead and record the data points. So it says for fish oil, we got 8, 12. So let's do that. So we got 8, 12. We got 10, of course. We got 14. We got 2. We got 0 twice. All right, and we got -6 here. 0, 1, 2. We got -3. -4. Oops, I put it in the wrong spot. That's -7. -4 is here, and -3 is here. And then we got 2. Okay. All right, so then you can see, okay, so there doesn't appear to be any strong skewness or outliers here. based on the two dot plots. Okay, so we can go ahead and proceed, which we knew that was going to happen. And then let's take a look at the do stage. So now I'm going to do do. All right, so we need to calculate. We need to do a we need to calculate the x bar for these two, x bar 1, x bar 2, and sx1, sx2. And we're going to need to do it separately. Okay, so it's probably better to just do a do it on a 2 sample t-test and then just get all these values. Okay, so that's what we're going to do. All right, so we're on the calculator. So we're going to go ahead and go to Stat, Edit, and we're going to put our lists. So these are our lists. This is for the fish oil group, L1, and then L2 is for the regular oil group. So I went ahead and typed that in. So then you would type those data in, then you would hit Stat, go to Tests, and then go to 2 sample t-test. So number 4. We got list 1 and list 2. We're going to choose data because we have data provided. You can ignore the frequency. You don't have to deal with that. Now here, it was a one-tailed test. We wanted to see if the blood pressure decreased, and that decrease meant greater than 0. So we're going to put greater than. And then we're never going to choose yes for this. Okay, never choose yes for the pooled. Just leave it at no. And then we're going to go to calculate. All right, and so this gives us our x bar 1. This gives us our x bar 2. This gives us also, if you scroll down, our S1 and S2. All right, so I'm going to write all these values down, and then we'll go from there. Okay. All right, so we got all the values, so I'm going to go ahead and list them all out. So we got. So I'm going to say 2 samp t-test, right? Or it was a 2 samp t-test on the calculator. Okay, and then we're going to go ahead and put the things here. X bar 1 equals 6.571. S1 is 5.855. We got N1 equals 7. We got X bar 2 is negative 1.143. I'm just rounding this to 3 decimals. S2 is 3.185. And 2 is 7. And they did give us our T, so we would have to provide that as well. So I'm going to also put the T is 3.06, and then the P-value is 0.0065. And this is what you would need to provide in the do stage so that you're good. You got your t-score, you got your p-value, and all of that. And then you would technically be done at the do stage. However, I'm going to do the calculation because I want you also to be familiar with the calculation, not just to rely on the calculator. You can rely on the calculator for the FRQ as long as you provide these values. However, I like to also make sure that you know how to do the calculations, okay? All right, so I'm going to do the calculations here. All right, so, oh yeah, also, we would need to know what our, let's see. Actually, yeah, so this is what you would get on using the DF equals 6, right? So, or yeah, no, actually this is on the calculator. And then we need to also provide the degree of freedom, okay? So degree of freedom from the calculator is 9.264, okay? All right, so again, if you use this on the calculator, it'd be a lot simpler. You get the answer, but I also like to do the calculation as well. Okay, so we got x bar 1 minus x bar 2 minus 0 divided by square root s squared 1 over n1 plus s squared 2 over n2. We got 6.571 minus negative 1.143 minus 0 over square root of 5.855 squared divided by 7 plus 3.185 squared divided by 7. Okay, and you would do that and you would get about 3.06, which is what the calculator got. And then, I like to label the graph, and we know that we're doing a right-tailed test. We got 3.06 for our t, and then it's a right-tailed test, okay? All right, I like to label a graph and do all that, but we can conclude because we have enough information, because we already did our 2-sample t-test on the calculator. We got our p-value. All right, so we can go ahead and say because the p-value of 0.0065 is less than alpha equals 0.05. We reject H sub 0. We reject the null hypothesis. We have convincing evidence. Fish oil helps reduce blood pressure more on average. Gotta make sure you include that. Than regular oil for subjects like these. Okay, there you go. All right, so now let's look at the part B. It says interpret the p-value from part A in the context. Remember, to interpret the p-value, you assume HO is true, okay? And then when you assume HO is true, then you have a certain probability that the result is as strong or stronger by chance, okay? All right, so assuming all right, hold on a second. All right, so we got assuming the true mean reduction and blood pressure is the same, regardless of whether one takes regular or fish oil. There is a 0.0065 probability that we would observe a difference in the sample means. Sample means are the x bars, right? X bar 1 minus x bar 2 of 0, or we got, what did we get for the difference? I didn't write it down. So so the difference was, let me put what the difference was. So the difference was this numerator, which is 6.571 minus negative 1.143. Double negative turns into positive, so really you're adding these. So when you add this, you get 7.714. All right, so that's your difference. We got 7.714. So a difference of 7.714 or greater. How do we know it's greater? Well, because it's a right-tailed test. See that? Is that result or greater? Okay, or greater by chance alone. All right, let's see here. And that should do it. That's it for the video, guys. Hope you found this useful and informative, and as usual, I'll see you in the next one.